Yeah. Hi everyone. So I am Dibyaprakash Pradhan. I work as senior software engineer in GeekyAnts here. And first of all, thank you everyone for joining us today. And it's really nice to see you guys are participating in meetups. So yeah, let's get started. So our topic is diving deep into GraalVM, and we will talk about observability using Micrometer as well. Okay. So, as Vasuki told, like Spring Boot provides us a lot of Spring Boot starters, you can say, like even if it's security or you want to build some application which integrates database, or even if you are looking for any other solution. So Spring Boot provides a lot of starters. Okay. So it basically helps us to avoid boilerplates, but at the same time, it gives you a lot of unused code, you say. Okay, even if you are not using some code, the starter will include that in your final package. Okay, so the problem is it increases the jar file size, you can say, and not everyone of us prefers big jar files, and that is a problem for some people. Okay, because of we sometimes we restrict ourselves for infrastructure scaling, so we will try to understand how GraalVM can solve that problem. Okay. So yeah, let's get started. Yeah. So first of all, what is GraalVM? So you can say GraalVM is a high performance runtime. It's does the same thing like what JVM does, but in a different way. You can say JVM, using JVM. If you are packaging one jar, then you can run it on top of JVM. But GraalVM is something which creates native executables which can be executed in your native environment. So that is the difference, you can say. And yeah, so let's understand how it works. So it supports Java, Kotlin, Scala, and Groovy. So whichever language is supported by JVM, GraalVM supports all those languages. And GraalVM provides two type of compilers. One is JIT and another one is AOT. So basically, this JIT is not the exact one as the JVM provides. This is a better form of JIT, you can say. So yeah, GraalVM provides two options for you. So you can either choose JIT or AOT. So JIT is as you all know, it's just in-time compiler, which basically JVM uses, you can say Java hotspot VM uses. And AOT is something which is a part of GraalVM, you can say environment. And the full form of AOT is ahead of time compiler. And as it says ahead of time, what it does is it basically before runtime, it builds one native executable for you, so that there will be no loading of external classes or configurations during runtime. Okay, so that is the purpose. So we will just understand more about it next ones. Yeah. So here I have listed few highlights about GraalVM. So you can say great features of GraalVM. So first one is it starts first, and we will understand how it starts first, and what is the internal working of GraalVM, how it helps to start first. And next is low resource uses. So basically, if you are creating any native executable using GraalVM, whenever you will run it, it will really use less resources of your infrastructure comparing to JVM based jar executables. Okay. So and next is it minimizes vulnerability. How it does, we will understand that in later. And last one is it provides you compact packaging. Okay. So first let's understand the start first feature. Okay. Yeah. So here you can see we have the native image build process, how it builds the native image. So in the left side, you can see it takes input of all the classes from application, libraries, and VM, and it starts analyzing in a iterative way, you can say. Okay. So first it finds the point to analyze, then it runs the initializations, all the necessary initializations, then it does one heap snapshotting. Okay, so you might be like getting question like, what is heap snapshotting here? What is the work of heap snapshotting? So basically, GraalVM takes one snapshot of your heap so that it can predict like how much resource will be required for that particular native executable, and it will allocate that much resource only, so that like extra like additional resources will not be wasted like in runtime. Okay, so next is it will analyze all these all your code first, okay, in an iterative way. So what it does is this AOT compiler like first finds your main class, and it considered your main class as the entry point your application. Okay, so first it runs one reachability test actually. So like from the main entry point, it start analyzing where your functionalities goes. Okay, so you can say for an example, like you have some code declare like service IMPLs or some other like utils. Okay, and you are not using that anywhere in your application, like from the flow or the controller to service layer, like you are not using that. So what AOT will do is like AOT will remove all those unused components like completely. Okay, so that it can be a like smaller executable file. Okay, and yeah, so after doing all these steps, AOT writes your code in text section like of the native executable, which is your output, and also like image if it will put in data section. Yeah. So next is like let's understand like how these both compilers works. Okay. So first one is JIT. So as you can see, like it goes through a lot of process in order to create one jar. Okay. So in order to execute your jar, you can say first it loads the jar file from your disk, and then it uncompress the class files, verify class definitions, and execute in interpreter. Like I have mentioned there, like this is 20x slower than the GraalVM. Okay, and it impacts your timing, startup time as well, you can say. And next, it will gather profiling feedback, then compile to machine code, and at last, finally, it will execute at peak performance. But if you will see the AOT compiler here, it will just load the executable from disk, and it will start executing at the peak performance. Yeah, so that was all about the start first, and like it really helps to start up your application in a very less time frame. And next is low resource usage. So let's understand how it works. Yeah, so here we will do the same comparison between JIT and AOT. So here you can see like we have many components in JIT, like garbage collector and VMs and runtime compiler, everything. And along with that, you have like dynamic code cache and metaspace class files and feedback component. You have application payload. Okay, all this stuff. And if you will see AOT, it has like very minimal stuff. One is GC, application machine code, and application payload. Okay, so this is the component structure, you can say, in between these two compilers. Okay, so if you will see, yeah, so here I tried to provide one resolution on memory scalability. So whenever you are scaling your application, so you can say like you are scaling your pod. So now if you are using JIT, then it will increase. You can see these garbage collector and this BM and compiler. These are the only shared resources. Okay. So if you are increasing your like count, you can say replica set to 4, then only GC and VM will be shared in between all those 4 replicas, and all other stuffs will be duplicated. Okay, and if you will see the AOT, it also shares the GC and machine code, but only thing which will be duplicated is the application payload. Okay, so you can consider how less resource it will use. Okay, in terms of memory scalability. Yeah. Next feature is like minimize vulnerability. So how it does, we will see. So yeah. So I have listed some points here. So as I said, there will be no new unknown code can be loaded at the runtime, because it does the AOT compilation, right? Ahead of time compilation, and it gives you one native executable. So there will be no new unknown code can be loaded at runtime. So only paths proven reachable by the application are included. So like as I told, like it performs one reachability test. So it like checks which codes are like reachable. Okay. So if any other like unused codes are there, which might like create one security risk for your application, it will just remove those. Okay. So and it will not allow you like anyone to like reach that particular point also. And next is reflection is disabled by default. So you can say like this is a positive point as well as one negative point. So as you know, like reflection helps out a lot in like Java coding, you can say. But yeah, it's disabled by default, but it provides you like option to configure like to enable reflections as well. Okay. So if you will provide instruction to GraalVM, so according to your instruction it will include those features. It's not like it will include by default. Okay. And yeah, so deserialization and only enabled for specified list of classes. So basically deserialization is also like disabled by default for like custom classes, you can say. If you want to like enable deserialization, again you can just like give instruction to your GraalVM and it will do it for you. Yeah, that is how like it reduces like attack surface a lot. Okay. Yeah, the last one is compact packaging. So I will just show you one like funnel chart here. So I have collected this data from one Spring official you can say, like they have performed live tests like using GraalVM, and this was the output. Okay, so on the right hand side, like the like unit is MB. Okay, I forgot to mention. So first you can see. So like I have separated the you can say values with two colors, like red is for JVM and you can say green is for GraalVM. Okay, so in the first line you can see the Debian, like they have used Debian Slim and JDK 17, and the jar produced was a like size of was having size of 385 MB. Then they have used distroless Java 17 and it got reduced to 231. Those are like JVM use cases, I'm saying. And next they have tried like distroless Java base with JLink, and like again size got reduced to 74.9 MB. And like followed by that, like you can see 58.7. So that was the like minimum like you can say possible size of your jar. Okay, so next we starts with like GraalVM based executables. So you can see here we have used distroless Java base. So one static executable we have produced, and that was like having a size of 39 MB, and you can say 25 MB followed by that 21. And at last, if you will see, like it was scratch compressed. Okay, only the used codes were included in that particular native executable, and the size is only 5.4 MB. So yeah, it's surprising because like we cannot like do that using JVM, right? Yeah. So here are some like test cases we have performed, and the top one is like using this MVN Spring Boot run command, and you can see the application takes like 1.643 seconds to get started. And the second one is like you can say GraalVM native executable. So we have just run the command and it got started in zero point 0.3 seconds. And like these two applications were same. Okay, so you can like clearly see the difference between the startup time. So yeah, one more thing I would like to mention, like this is just a like normal application without having like any major functionalities. So when you will add the functionality to your application, like if you are like using any database, or if you are like building a lot of APIs and you are including some heavy components, then a startup time will be usually higher in like normal run method, right? So it might take 20 or 30 seconds. But now like you will see like here you can see very less difference. But when the startup time of JVM is like taking 25 seconds or something, that time GraalVM will take 3 or 4 seconds, I can say. Okay, so you guys can like just give it a try and you can check with your use case. Yeah. So next is so this is the like resource usage graph, you can say. So left side is JVM, Java Hotspot VM. So when that particular application started, this is the like usage graph, you can say. Okay, so the red spikes are showing the CPU usage, and the blue one is showing like RAM usage. So using JVM, you can see the spikes on time of startup, because it loads a lot of runtime configurations. Okay, so it will obviously use your resources. And if you will see GraalVM, there is a really like stable spikes. So you can see like it use your CPU less as well as your RAM. Yeah. So that was all about like GraalVM. And you guys can just give a try to GraalVM. So anyone of you have used like GraalVM? No one? Okay, just give it a try, and like it might not suit your use case, or it might suit your use case, but yeah, just give it a try. Yeah, I didn't include the like drawbacks of using GraalVM, because I want you guys to give it a try. So yeah, next, so let's talk about observability. So observability is like something, you can say, the ability to monitor, or to you can say, how you can say, like your application is running somewhere, and you don't want to disturb the running process of your application. You don't want to open server and check the console logs. Okay, so and like by using external, like being the external part of like accessing, you can collect some data from your application, matrices and logs, you can say. So like for each API education, how much time it's taking, like the trace points, like where exactly your request went, like when it hits your application, and what happened to that like request. Okay, if error is there, then what is the reason of that error, and in which component that error is produced. Okay, so without if you want to see that without opening your console logs or something like that, so you can directly like use observability. And we have one like provider is like called as Micrometer. Yeah. So what is Micrometer? Micrometer is a library, you can say. It simplifies the collection and reporting of application matrices by providing consistent dimensional first. So what is dimensional first? Like it doesn't look for only one dimension. It means like it doesn't look only for error logs or normal logs, you can say, or matrices. It looks into all the dimensions. It gathers the data in a proper like structured format, and it gives you back. And yeah, so that is it. And yeah, it helps you like a lot in terms of troubleshooting your application, or like optimizing your software. Yeah. Next is Micrometer is in Spring Boot. And Micrometer observation API is a like new type of API, as they say. And this allows us to hide the low level APIs such as metrics, logging, and tracing. So these three are like different components. So for metrics, you might use some different component. For logging, you might use some different component, native logging or asynchronous logging, distributed logging, I can say. And for tracing also, you might use different, like you can use GeekyAnts for tracing or something like that. But Micrometer provides you all these things like in one place. So they call it as observation instead of calling three words. So how it works? So first of all, like we can include these dependencies like from io.micrometer. So you can include core for core functionality, and you can include micrometer tracing if you want to like enable more tracing functionality in your application. So first, you will create one observation registry here, and then you will create one observation object, and like you can just mention the like identifier, as I mentioned sample here. So you can start the observation by calling the start method. So there are two ways, like to write the code you want to observe. So the top one is like you can use this try, catch, and finally for writing the code which you want to observe. And or simply you can use this like dot observe, like lambda functions. Okay, and this is the like flow, you can say, like which shows like if it started, then like first it will be stopped, it will start. So this is the life cycle flow, you can say. And if any error is there, it will say like send and collect the error. And next is like scope, like life cycle. And there is two, like one is open, scope open, and scope closed. So this can be done multiple times, and scopes can be nested, so it will be keep on nesting the scopes for your observability point of view. Yeah. So, yeah, that was it. Thank you so much.